Welcome to Module 6. In this module, we'll talk about the path and information disclosure vulnerabilities. The vulnerability occurs when an incorrect script execution returns an error on a website, which reveals too much information to visitors. While this feature is helpful in developing an application or searching websites for errors, it may at times lead to an information disclosure that enables a hacker to see the full service structure and search it for potential weaknesses. Let's see a sample script which illustrates the problem. This simple script first connects to the database we've earlier created for this presentation, and then includes a second file, main.php. User input entered into the file is used to generate an SQL query that loads articles from the database. If the query is successful, the site will display the article. If it fails, the site displays an error message containing the SQL query which provoked the error. This might be helpful while building web applications. When visitors find errors, they can report it to administrators, making website building easier and faster. Unfortunately, a potential attacker may use the disclosed information to exploit other application vulnerabilities. Let's now see in practice how the script works. The database identifier 1 holds an empty article, so entering this path won't cause errors. What will happen, though, if we pass an invalid identifier, which will cause the SQL query to be syntactically and grammatically ill-formed? As we can see, the generated query is incorrect. 1a is not a numerical value and should be placed in quotes. If this error occurs, the content of the query is displayed. This dangerous revelation allows an attacker to realize that the service may be exploited through the SQL injection vulnerability, a type of vulnerability which will be discussed later. Moreover, the names of the fields and tables used in the database are also revealed to the hacker, which makes the potential attack even easier. Let's go back to our script for a moment. As you can see, we don't check if the ID parameter has been given at all. What could happen if this is not specified? It turns out that the PHP interpreter has returned more error notices. The messages disclose the number of the line which contains the error and file name in the full path. If the file name is hidden through, for example, mod rewrite, the message will display the original name of a PHP file. This exploit may also reveal the service structure with directories and, above all, disclose the path to the directory containing our web application. This could be exploited through a path traversal or PHP injection attack. As these types of data could be very useful for a potential hacker, it's essential to avoid information disclosure. Notice that the connection to the database is executed in index.php, while main.php assumes that the connection has already been set. What happens if the main.php file is launched in isolation? Both main.php and index.php are stored in the same directory, which is accessible by the user. As we can see, the execution of the script is not successful here, as the connection to the database has not been set. This results in more error notices. Let's think of how we may protect ourselves from these types of vulnerabilities and reduce the amount of output data when an error occurs. We may go back to the incorrect query discussed earlier. In that case, we could simply disable displaying SQL queries. While displaying them is a helpful feature for developers, the information should not be disclosed to all visitors. It's better to log the information into a file or only display the query after checking whether the current user has administrator or developer privileges. As you can see, the message has not been displayed now. Unfortunately, this does not solve the problem with returning error messages where no parameters are passed at all. It may be worthwhile to prepare yourself for all possible error scenarios. Errors may occur as a result of a user or service mistake. They may also happen as a result of a potential attacker testing the application for vulnerabilities. In such cases, our script could be called in a way which is not originally provided for. This is why it's useful to protect the application against at least several obvious problems. In this case, we could configure the script to check if a parameter has actually been given. The isSet function audits whether a given variable or identifier has been set. If it has not been set, an error is not returned. Instead, the value false is returned. As we can see, the error message has not been displayed. Let's now look into another scenario, launching main PHP in isolation. To demonstrate the process, we first need to get rid of the protection mechanism we've just implemented. As we can see, error messages are being displayed. We need to make sure that main PHP won't be launched in isolation. Here, you may enter a constant that signifies that the code needed for the script to run has been launched. For example, set the constant header run, which signifies that the code from index.php has been executed and may be utilized. The constant will be set in main PHP only if the file is included from within index.php. Let's see if this produces a change. As you can see, main PHP has not been executed at all in this case. We could also prevent the attack in another way. If the constant is not defined, the execution of script is blocked. If scripts are stored in another directory, you may try to use htaccess to quickly deny users access to these files. Reporting errors is also managed by the PHP ini configuration file. This is achieved through two variables: error reporting and display errors. Error reporting defines the types of errors which will be reported, while display error disables or enables displaying errors. If it is set to off, errors will not be reported. Let's switch it off. The Apache server needs to be restarted for the changes to take effect. Okay, as we can see, the code does not display errors. That's all in Module 6. Thanks for your attention and see you in Module 7, which will focus on forced browsing. See you there.